Question 9a says the table shows the height of teak trees harvested by a farmer. Find the median height. This is the height. We have the heights here. For the height, we have 3, 4, 5, 6, 7, 8 meters. Then the number of trees that fall under 3, we have 4. For 4, we have 6. For 5, height of 5 meters, we have 4 of them. For height of 6 meters, we have 5 of them. For the height of 7 meters, we have 6 of them. And for the height of 8 meters, we have 2 of them. Looking at this, we should understand that the number of trees represents the frequency and the height represents the x. To get the median height, we need to add the frequency, that's summation of the frequency, then add 1 to it. Then finally, we divide it by 2 and get our answer. The formula for finding the median of a group data is summation of the frequency plus 1 over 2. Since we have this, we'll add all of this together, 4 plus 6 plus 4 plus 5 plus 6 plus 2. If you add them up, they will give you 27. So the addition of all of this is 27. Median is equal to 27 plus 1 over 2. 27 plus 1 is 28 over 2. 28 divided by 2 will give you 14. This is the 14th position. Going back to the table, we have to find the 14th position. We start adding. You add 4 plus 6, that's 10. 10 plus 4, that's 14. So 14, the median point lies exactly at this point. And we know, therefore, our median height is equal to 5 meters. Part B.I says find the mean, and part B.II says find the standard deviation. For us to answer these two questions, we have to rearrange our table, and since we know this is our x and the lower one is our frequency, we will change our style of tabling. To find the mean and the standard deviation, we need to start by finding the mean, because for us to find the standard deviation, we need to have the mean to solve. So we'll start by rearranging. Since you know our height represents our x, this is where we have our height, and the number of trees on this side represents our frequency, so we can just write x on top and f here. And for us to find the mean, formula for mean says summation fx over summation f. First, we start by adding the frequency, which is our f, to get the summation of the frequency. So our total for it, like we've done before, will be 6 plus 4 plus 4 plus 5 plus 6 plus 2 will give us 27. Next, we need to find our fx. That's multiplying your x times your f for each line. So we have 3 times 4, 12, 4 times 6, 24, 5 times 4, 20, 6 times 5, 30, 7 times 6, 42, and 8 times 2, 16. We add them up, that is summation of our fx. We have 12 plus 24 plus 20 plus 30 plus 42 plus 16. It will give us 144. And for us to find our mean, as stated below, we have our mean as summation of fx over summation of frequency. And you know our fx is 144 and our frequency is 27. 144 divided by 27 will give you 5.33, which is 5.3 to 1 decimal place, or dp. The next question, 9bii, says find the standard deviation of the table. And for us, there's a formula for finding standard deviation. The formula says square root summation frequency into open bracket x minus x bar close bracket all squared over the summation of the frequency. We have our formula, then we'll start by x minus x bar, or x minus the mean. We square it, then we multiply it by the frequency, add it all together over the summation of the frequency, which is 27, as we found before. So we'll start with x minus x bar, which is the mean. The values for x are on this line, so we have them as 3, 4, 5, 6, 7, 8. So we'll subtract each of them by the mean. So we have, for the first one, we'll have 3 minus 5.3. 3 minus 5.3 will give us minus 2.3. Next, we take 4 minus 5.3. That will give us minus 1.3. That's 5 minus the mean. The mean is 5.3. Will give us minus 0.3. The next is 6 minus the mean will give us 0.7. 7 minus the mean, which is 5.3, will give us 1.7. And 8 minus 5.3, the mean, will give us 2.7. On the next line, or on the next table, we have x minus x bar all squared. So we'll square each of these. That's minus 2.3 times minus 2.3. Minus 2.3 times minus 2.3. The minus will multiply the minus to give us positive. Then 2.3 times 2.3 will give us 5.29. Minus 1.3 squared, that's minus 1.3 times minus 1.3 will give us 1.69. Minus 0.3 times minus 0.3 will give us 0.09. 0.7 times 0.7 will give us 0.49. 1.7 times 1.7 will give us 2.89. And 2.7 squared, or 2.7 times 2.7, will give us 7.29. The next table we'll have is f into open bracket x minus x bar, or the mean, all squared. These values we have derived from x minus x bar all squared. We'll multiply it by the frequency on the same line. So we have like 4 times 5.29. We have 6 times 1.69. Let's start with the first one. Say 4 times 5.29 will give us 21.16. 6 times 1.69 will give us 10.14. 4 times 0.09 will give us 0.36. We have 5 times 0.49 will give you 2.45. We have 6 times 2.89 will give us 17.34. And the last, we have 2 times 7.29 will give us 14.58. And looking at the formula, we've done f into open bracket x minus x bar, which is the mean, all squared. Now we're going to do the summation. That means the addition of all of these values. The addition of 21.16, 10.14, 0.36, 2.45, 17.34, and 14.58 is 66.03. As said earlier in the video, we know the formula for standard deviation is square root of summation of frequency times x minus x bar all squared over summation of the frequency. And we've calculated our summation for the frequency times into open bracket x minus mean close bracket all squared, which is 66.03. So we have square root of 66.03 over summation of the frequency, which is 27. This is equal to square root of 66.03 divided by 27 will give us 2.45. And square root of 2.45 is 1.57, which is approximately 1.6. Our standard deviation is therefore 1.6.